So now that we've talked a little bit about how the overall project is structured, let's talk about the way the quotes server is designed, what its structure and functionality is. And again, keep in mind that that's got a couple of controllers, and it uses the RSocket protocol to do back pressure aware communication with a client. So the Quotes Connect controller and the Quotes Connect service handle connection requests from clients. And you'll see we have two of these things, and we'll talk about the various methods and the fields and stuff like that in here in a second. So the Quotes Connect controller is a controller, not a REST controller. It's a good old controller, and that enables it to do class path scanning and dependency injection and all that kind of good stuff. Similar to a REST controller, just doesn't use REST. It's connected via auto wiring to the Quotes Connect service. No real surprise there. It's got a single method called handle connect, and this is a method that's called back whenever the client establishes as a connection. We'll talk more about that later when we see how this is done. And you can see it passes over the identity of the client requester, so the server can talk back to it, as well as the identity of the client. We do this, we get this thing wired up so it'll be able to handle connection events by using the connect mapping annotation with the server connect path. So that basically says, hey, if somebody sends a connection request, which occurs implicitly, to the server connect path, then send it here, please, route it here. And then it forwards to the service that actually does the interesting stuff. Here is the service that does the interesting stuff. It's a service, no surprise there. It's got a map that maps the connected clients to the identities of the connected clients. The clients will identify themselves using a random UUID string. And we have a map that maps that string to the RSocket requester, which is what the client sends over when it connects, so that the server can talk back to the client. That allows this bidirectional requester-responder style communication. And one of the things I've noticed with playing around with this is it appears that connection-related events can occur concurrently. And that's why I use a concurrent hash map. It's a little hard to figure out from reading the documentation exactly how Spring concurrency works with RSocket, but in putting a lot of debugging statements in, I think I've figured out that this appears like it can be accessed by different threads. Here's the handle connect method. As you can see, it takes the client requester and the identity of the client. Those are passed over when the connection's established. And it does two things, which we'll talk about in more detail. It sets up a little mono chain to handle client status changes, like if the client ends up shutting down, or there's an error, or really just the first time the client connects. It does some stuff to update this map. And then it also finalizes the connection setup, which involves communicating back from the server to the client saying, I received your connection request, and we're all synchronized now. And then it gets back an acknowledgement that says, OK, fine. So at that point, everything's ready to go, and events can flow. Let's now talk a little bit about the structure and functionality of the quote message classes. There are two of them. There's the quote message controller and the quote message service. And of course, they handle client messages, as you might expect. So the quote message controller enables clients to receive the quotes. And so by subscribe here, what we mean is that the client has to indicate a subscription before they start getting quotes. And the subscription, as we'll see, contains several fields, the most important of which is which type of quotes they want. Do they want a zippy quote? Do they want a handy quote? And right now, you have to choose one or the other. I should probably make it so you can get both. But that's what it does at this point. So what we have here is a controller. And that means that this is a controller, just like we did for the quotes connect controller. We auto-wire a quotes message service. And then we've got a couple of message mappings. Message mappings are the annotations that are used in Spring RSocket to indicate route messages to me, please. And in this particular case, we have just a couple examples. We got more than this, but these are just two I show here. We have the subscribe and the get all quotes messages. Subscribe confirms a client subscription request, basically says, OK, I know you're ready to go. And get all quotes goes ahead and gets a flux that emits the specified quote objects. Here's the quote message service. It's got a couple of auto-wired fields that keep track of the handy quotes and the zippy quotes. And we use the qualifier annotation to indicate which bean should be used to initialize the respective quotes list. And this should say M quotes list, not M quotes. We also have a set that keeps track of the client subscriptions, so we can check to see whether they've subscribed. This particular RSocket server uses a single-threaded event loop. And again, I've been playing around with it, trying to see if I can get it to use multiple threads. I couldn't seem to do that, so I think it's OK to use a non-concurrent set here. But if you're paranoid, and I probably should be paranoid, you probably want to use some kind of concurrent set, such as a hash view, the concurrent hash map, key set view abstraction, or some other set that supports concurrent access. Here's what the subscribe method does. It basically takes a subscription request that was sent over by the client, and it goes ahead and confirms it by changing the status of the request to confirmed, and then adding that into the set so we know it's been registered. And then we return the confirmed subscription. So that comes back to the client so that it can use that when it wants to receive quotes. Here's the getAllQuotes method in the service, and it is given a subscription request. And what that does is it's going to return a flux containing all the quotes that are relevant. If the subscription request is not in the map, then we would just return an empty mono. We should probably throw an exception, but we just return an empty mono saying there's nothing there. If it is in the map, then what we do is we go ahead and we check to see what kind of subscription. Are we subscribed to the zippy quotes? Are we subscribed to the handy quotes? This should say zippy. So if it's zippy, then it returns the zippy quotes. Otherwise, it returns the handy quotes. And that will then come back and stream back to the client using the back pressure policies that the client has put into place. Notice that the server doesn't really know the back pressure policies are put in place. It's relying on the client to do that. So there's lots more stuff where this came from, to quote Napoleon Dynamite, and we'll take a look at some of the other methods and fields when we take a look at the code in more detail. All right, so that's the end of the RSocket Quotes server structure and functionality.